Hey everybody, welcome to video 3 in the basic electrical series. So hopefully you watch videos 1 and 2 because this sort of is a build a bear process. We need to be able to start from a base and then work our way up. So if you haven't watched those 2 videos, make sure you watch basic electrical 1 and basic electrical 2 and then you'll be ready for this video. So in this video, we're going to talk about what a complete circuit needs to run or to work. I actually have a circuit board here with me so I can show you in real life. So it makes things a lot more fun than just writing stuff up on a whiteboard. So we're going to talk about what a basic circuit needs to just do the thing. And then we're going to talk about 2 very close terms to me and near and dear to my heart: continuity and grounds and how they work. So first things first, what does a complete circuit need? Number of things. First things first, we can't make those electrons move unless we give it a charge or a pressure, right? So we need a power source. And in the case in automotive, that is going to be our car battery. The next thing we need in our circuit, and this is a must-have, both of these, actually really 4 of these are must-haves. The next one is a power path, meaning whatever it is that I'm doing in my circuit from my power source on one end, we'll go ahead and just say positive for now. So from my positive, I need a path to what I'm doing in the circuit. That is my power path. Now down here it says load, and I have to have a load in my circuit. In this case, I've got a light bulb as my load. The load is going to be whatever you're doing work-wise in the circuit. If I'm producing light, or the circuit's producing light, I'm not producing light. But if the circuit's producing light, if it's producing movement, heat, all that fun stuff, whatever is doing that, that's the load in the circuit. Now, most of the time we try to engineer the loads into our circuit so it's purposeful, right? I want to light this light bulb. But there are some times where we end up with loads that are unintentional, stuff like corrosion are problems for our circuits, and they actually create problems with the way our circuits function. If you're familiar with corrosion, it's that sort of crusty buildup that can happen in electrical wiring or on batteries and things like that. We'll get into that later when we get into electrical faults. But that would be an unintentional load, and those will produce a heat, again, unintentionally. But the load in the circuit must be there. Now, if you have everything else in the circuit, but you don't have a load and the circuit is connected, we'll say it has continuity, I'll explain that in a moment, then electricity will find a load. And what it will do is, remember that teeter-totter, amperage and resistance? Well, if my resistance, again, the load in the circuit is what is providing that electrical resistance. Everything else in the circuit does not really have a significant amount of resistance. So we start to get unbalanced here, and if I have no or little to no resistance in the circuit, guess what happens to amperage? And there is a limit in your circuit. The gauge of wire is going to limit your amperage flow and all that good stuff. So if I start to get this insane increase in amperage, what we have is a fire. And we'll explain that later when we get into faults and what that looks like in Ohm's law and all that good stuff. But we need to have an electrical load. If not, electricity will use up all of the voltage, but it will be more in the event of producing heat unintentionally, in the form of fire. Most of the time it will just melt the wires until they are disconnected, and now you don't have a complete circuit anymore. The last thing you must have, again, a must-have, is going to be your ground path. Now the ground path, we right now can just say negative. I'll explain grounds in a moment, but we have a power path going to the load. I must have a path that is coming from my load all the way back to the battery. I must have this circle, essentially. If we call that circle continuity, I'll explain in a moment. But if I don't have this circle, we can't produce light, just matter of fact. Now down here in green, I actually accidentally smudged it, but in green we've got some optional devices, and I didn't explain these 2 here. So one of them is circuit protection. Circuit protection is going to be put in the circuit. In this case, I put a symbol for a fuse, but that can be something like a fuse, a fusible link, a circuit breaker, something that is going to protect the circuit. So if I just have a simple circuit of just my power source, just a wire to my load for power path, and just a wire coming back to ground without circuit protection, if for whatever reason I get a spike in amperage, which can happen due to a couple of reasons we'll explain later, but if I get an event where I have a spike in amperage, we are just going to burn up the wire and it will catch on fire. Many of you have probably seen these vehicles on the side of the road from poorly wired sound systems and things like that, right? Or poorly wired hydraulic systems. So that's what you don't want. That's why we put in circuit protection, and we'll explain later why it's actually really important to put that circuit protection as close to the battery on our positive side as possible. If you start to put it further back, especially sound systems, you start to put that fuse toward the back, that's how we get fires. So just to keep that in mind, circuit protection isn't necessary to make the load do the work, but it is a nice cushion to have in the event you have an issue, right? The last one down here is what we call our control device. I should probably get out of the way so you could read that. So this is our control device. Our control device is what you might think. Wouldn't it be nice if this light bulb wasn't on all the time and say only on when I want it to be on? That's where our switch comes in. And there are many different types of switches. Single pole, single throw double, or single pole, double throw, momentary contact. There's all sorts of fun, cool little switches that we can get into when you get into an electrical class. But just for the basic level, all you need to know is that a control device is optional. It's really about convenience rather than a necessity. We don't necessarily have to have the switch in order to make the light bulb work. And I will show you right now in our circuit, and actually it works to my advantage that my lighting is starting to go away here because we'll see the light better. Here is my electro trainer. So the electro trainer here, I'm going to open it up. This is what we use at school, and if we were back on campus, y'all would get each one of these and you'd be put into groups and you guys would get to build circuits yourself. But for right now, this is what we got, so we'll make do. So inside I have a power source. This is my battery. I've got this thing plugged into the wall, so this is going to be my power source. I need to turn my power source on. Now I can see I've got a light here telling me that my system is on. I've got red on one side and I've got black on the other side, indicating a positive and a negative. I've got my light bulb right here. It's not connected anything through here. This is just almost like Legos just to hold it in place for me. Let me grab, I should have a switch here, so we'll go ahead and grab that. So just like the circuit I built here, we're going to build that on here. I will go ahead and put my switch, right next to my power source, positive. Well, again, the Easter Bunny exists, Santa Claus is coming to town, all that fun stuff. And this right here, you guys probably can't see. This is actually a fused cable. So if I take this apart, it actually has a glass fuse in there. We're going to talk fuses later on in a future video. So I will show you guys actual pictures of that fun stuff and how they actually work. I have a slide for it to show you. So I'm going to connect a power path from my positive through a fuse to my switch. I'm using a just a regular old toggle switch. So this is actually considered what we would call an SPST, single pole, single throw. We don't need to get into that right now. That is connected to my switch. I'm going to go ahead and grab another wire here to go from my switch. I'm building it just like this, from my switch to the light bulb. Now you'll notice I created a power path, and I'm hoping that my lighting doesn't suck too bad. Let me see if I can do anything about this. I don't think so. No biggie. I've got my power path going from my positive through the fuse to the switch, out of the switch into my light bulb. A straight line, just like I've got my drawing up here. Why isn't my light bulb lighting up? because we're missing that crucial piece. They're all four of these are crucial pieces. I need a ground path going back to my power source, right? So I've got another cable here. I will go ahead and connect from the light bulb back to my power source. And let's see what we've got here. We've got light. And since I've got a control device, I can turn my light on and off. Now, with this in place, again, if I take away my ground path, no light. If I take away my power path, no light. Now, let's go ahead and remove our fuse and our switch. Can I make the light bulb light still? Power path, power source, power path, load, ground path. That's all you need to make this circuit work. The others are optional. Like I said, they are out of convenience, and so we don't light our cars on fire when things go wrong, because things always go wrong. That's why we have a job, right? Because things go wrong as automotive technicians. So that takes me actually perfectly from what a complete circuit needs into the next topic, which is a term you need to write down, put on a Post-it note on the fridge, write it on your forehead, get it tattooed on your wrist: continuity. Because continuity is the key to our circuit working. No continuity, no circuit worky. So what is continuity? Is the continuous path for current to flow. It is simply a circle. It is, again, Easter Monday exists. Santa Claus is coming to town. I'm drawing arrows here from positive to negative, but it's easy to remember that way. It is this constant circle or path for flow. Now, it doesn't mean that it's actually flowing. It means we have a path for it. No path, no flow. No flow, no worky. It's as simple as that. And this is something that's just it's such a key element in automotive electrical diagnostics. It's almost like when you're young, playing baseball or any sport where you're playing with a ball. I played softball in my younger days, so a key thing that they used to tell us, especially when you're in the little leagues and you're trying to get good, is keep your eye on the ball. And even as I got older, they always say that: keep your eye on the ball, keep your eye on the ball. And it used to irritate me because I'm like, duh, we're playing softball. Or if you were playing baseball or football or whatever, we're watching it. That's the whole point of why we're here. Duh, I know. But do you really? Because if you manage, and again, if you didn't play these sports, then maybe this analogy doesn't work, but it's what I know. So if you can make sure to actually really focus, and as a batter, or if you're in the outfield or in the infield, if you are so focused on that ball that nothing else exists, it actually becomes hard to not hit the ball or to not catch the ball. If you truly focus on the ball, keep your eye on the ball. It seems basic, but if you really, really take it to heart and understand it, you become 10 times the player that you did. At least that's how it was for me. It was like it clicked one day and I was like, oh my God, duh. That's continuity. So continuous path for current to flow. If I don't have continuity, I do not have a light bulb to work. If I break my path on either side of the bulb, before the bulb, after the bulb, it doesn't matter. If I break my path at any point in time, no flow will happen and no voltage can get used up for anything. So I just really need you to keep that in mind. With that being said, I am going to get electrical pressure. And again, in automotive, we're talking conventional theory here. But let's just say our voltage, we've got electrical pressure coming up to our bulb. Our bulb uses up all the electrical pressure, and I've got nothing out here. Let me actually take my meter here, and I will show you what we have. I'm getting a little excited here. We will bring out the meter. I'll show you guys how to hook it up next week, I promise. But right now, I'm just going to get in here because it's easy for me to show you a number on here. So I'm going to set my meter to voltage, and I am going to show you, first off, always test your power source first. So I'm going to see from my positive side to my negative side, I've got 12.87 volts. Not important. Let's just say 12 volts right now. That is testing from, I'm essentially testing across the battery how much pressure my power source has. Now what's important to know is how much is going into the bulb and how much is coming out of the bulb. So what we're going to do here is I'm going to take one of my leads, because this meter tells the difference between my red lead and my black lead. That's all you need to know right now. We'll talk about it in detail later. I want to know the difference. I want to know how much voltage is coming into my battery, or I'm sorry, into my light bulb, and I want to know how much is coming out. Well, in order for me to know that, I need to be able to have a constant zero. And so that's going to be on my ground side in this case, so we'll go ahead and put that over here. Now let's go ahead and test how much voltage is coming into the light bulb. We know our power source is 12.8. Coming into the light bulb, coming out of that positive wire right here is 12.8 volts. What about coming out of the light bulb? What would you guess? I mean, I did mention earlier that we're not allowed to really have any voltage come back to the battery, so let's go ahead and test right there. I've got, sorry for the glare, essentially 0 volts coming out of my light bulb. So 12 coming in and 0 coming out. This light bulb is using up all of the pressure inside or coming from my power source. It can only do that if I have continuity. No continuity, no voltage drop. Let me show you something. So I'm going to take away our continuity. Oh, no more light. We're going to take away our ground path. Just going to leave it hanging here. In fact, I'll just put it there so we don't accidentally screw anything up. And let's get our meter back again. I am going to take our, mix my leads up. Our constant 0. And again, from my battery source, I've got 12 volts. Even with the light bulb not working, so I've got 12 volts of pressure coming into my light bulb here. We've got 12 volts coming in. So that's crazy, right? I've got voltage coming into the light bulb, but it's not lighting up. Because without continuity, I cannot drop voltage. I can't use any voltage if I don't have any current flow. Let me show you. So before the light bulb, after the light bulb. Oh my God. There is no voltage getting used up. How is that possible? Voltage going through the light bulb, but the light bulb not lighting up? Why not? There's no current flow because there's no continuity. That right there, ladies and gentlemen, is probably one of the most important things you need to understand when working on electrical. Because when you have an electrical circuit that doesn't work, this right here is going to pop into your head. And you're going to be like, oh yeah, maybe I should check to see if there's continuity. And not with a continuity tester. You can simply test for voltage until you see no more voltage. And then you can pinpoint where the problem is, because if I can see that I've got voltage coming out of my power source, going into my light bulb, coming out of my light bulb, if I go down to my ground source, or I'm sorry, my ground path, now I've got nothing. So I know that the break is somewhere after my light bulb to my ground or my negative. Boom. Now I know this is a basic electrical circuit, and obviously automotive cars or vehicles are much larger, but this basic concept is going to help you out a ton. So if you have any questions, make sure you comment or message me and let me know so I can help clarify this a little bit, or maybe I need to make another video to help clarify, but this is so, so, so important. So that is continuity. The last thing I want to talk about in this video before it starts to get a little too lengthy is another one that's really important, and that is grounds. Because we hear this term ground all the time, and I feel like it's really misunderstood. And many people would have an easier time diagnosing things if they understood what grounds actually were and what the term actually meant. So let's get rid of this here. Okay, so this is the conventional circuit or simple circuit that I've been drawing over and over, right? Again, positive power path to our load. Then from our load, we have a ground path. We're using the term ground path, but really it's a negative path. The term ground means something a little bit different. Now, right now, ground and negative is the same because we use our negative side of the circuit as a ground, but actually back in the day, Volkswagen used positive grounds. What does it even mean? So let me explain something for a moment. If car manufacturers had to run a wire with the fuse and the switch all the way to the load, let's say this is a headlight, and they had to run another wire all the way back to the battery for the negative, our wiring harnesses would be much larger, our vehicles would be heavier, and the cost of manufacturing would be higher. So what part of this are they taking out to save all of that? They're taking out this right here. Now, you're probably thinking, but we need that for continuity. Good job for thinking that. But we can get continuity in another way. Let's not forget the basic stuff that we know. Pretty much most metals are conductors, right? So isn't like the whole car made out of metal, right? It is, and that is where our grounds come into play. So what we did here is, I'm going to bring in a new symbol here. So our light bulb, our fuse, and our switch, I will explain symbols more so in the next video. This little worm is our fuse. This little box here is our switch. I'll explain those symbols, like I said, in the next video. The light bulb, I figured, is pretty self-explanatory. So I will go ahead and show you the new symbol just so we're not confused here. It is an upside down Wi-Fi symbol, or a Wi-Fi symbol, I guess, with a line going into it. That is the term for ground. Now, again, still haven't explained. You're like, Ms.A, but you haven't mentioned what ground is yet. So we know the symbol. What the hell is it? The reason why I need to say that is because in order to complete the circuit, I got to draw this symbol. Instead of making a wire from our load go all the way back to the battery, what we did is we utilized all the metal that the vehicle is made of. So I took my battery negative cable and I hooked it up. Not me, but vehicle manufacturers hooked it up to what we now call ground. Ground means the uninsulated side of the circuit. What does that mean? So if I take positive and I take negative and I touch them together. Some of you guys have probably done this at home. You created a little bit of welding or some sparking, and you're like, oh my God. That's because, remember I said electricity needs something to do? Well, if I take my load out and I shortcut that and I connect positive to negative directly, and there's no resistance, my amperage is going to be insane enough to actually heat up enough to create a fire or catch my wires on fire, or conductors on fire, but definitely enough to create some gnarly sparks and to possibly do some welding if you've got something on top of your battery. So I need to make sure that I separate my positive side of the circuit from the negative side of the circuit. So what we did was, and most of you guys have seen wiring, they're not bare wires. They have plastic or rubber covering on them, right? And the plastic or rubber covering on them is what we call insulation. Insulation simply protects, again, rubber or plastic, those are insulators, if you watch video number 1. And that insulation is going to keep that connection from happening. Therefore, we don't lose the resistance of our load in the circuit. Now, the uninsulated side of our circuit, only one of these sides needs to be insulated. As long as they're not touching, that's most important. So if I already insulated one side, and again, car manufacturers tend to insulate the positive side, I don't need to necessarily insulate the negative side of my circuit. And that's just a basic phrase. Don't say that, well, there are some negative wires that have insulation. Yes, it is. So not all negative wires are bare, but hopefully you understand when I say negative side of the circuit doesn't need to be insulated. So what that means is I can have the negative battery cable be completely bare if I want to. And what I can do is I can connect my negative battery cable to the vehicle's frame. If it's a frame over body type if it's unibody, then body and frame are one. If it's a body and frame type vehicle, then I'm going to connect a separate cable. So we'll connect, I'll show with a color here, we can connect my negative to the frame. From there, we're also going to connect to the body if it is in fact separate. And then no matter what, so again, if it's unibody, those are one and the same. But lastly, it's always going to need to connect to the engine block as well. So when we see this symbol, it is essentially saying it's connected to one of these. That's what that symbol means. And that's what ground is. So we're utilizing the frame, body, and engine of the vehicle, because they're all metal, as conductors. Because why run wires when you have this metal traveling from the back to the front of the vehicle? And it's no added weight because it already has to be there. So that's what we're talking about with grounds. So then, again, back to my circuit here, how do I make this light bulb light up? Because right now it has no continuity. I don't need a wire going all the way back to my battery. Since my battery's negative is connected to the frame, body, and engine, all I need to do is connect, and since I already have a power path, all I need to do is connect my light bulb to frame, body, or engine. Now, it is super important that these surfaces, these connections here and here, are to bare metal, because paint is a barrier and will not allow for that electrical connection to happen. So if you're hooking up a circuit and you're like, this isn't working, check your connections, make sure that there's no paint in between the barrier, take some sandpaper, get that paint off. But as long as this is connected to bare metal here on the frame, body, and engine, again, there might be 3 separate cables, or maybe it's just going to the unibody and the engine, so there might only be 2 cables there. And then I can hook this up to anywhere else that's bare metal on the vehicle that is frame, body, and engine. Not suspension or your wheels. We do have suspension bushings that are rubber, engine mounts that are rubber, which is why we have to have a separate connection here. And then obviously, since our suspension is rubber, anything down from the brakes and the wheels are not going to work as conductors for ground. So I eliminated all that wire. And right now it doesn't seem like that much because it's just a light bulb. But think of all the electronics in your vehicles in the front and the rear. it would be a whole lot more wiring if we had to add wires going to negative to everything. So instead, we just utilize all the metal on the vehicle to help us out as conductors, and that is what a ground is. So really, really important. This is a common point of failure because it's exposed and not insulated, because again, bare metal. So we get things like rust and we get things like corrosion. So when a circuit's not working, if you find that, let's say, a light bulb is dimmer than it usually is, or the motor's not spinning very fast, there could be an issue internal with the component, but one of the most common causes I've seen is corrosion in the circuit. And the first place I like to look for corrosion in the circuit is the ground, because it's not insulated. So we'll talk more about that when we get into circuit faults, but that is essentially what grounds do and how they work. So hopefully that makes sense. If you have any questions, please make sure that you message me or comment, and I will help you out the best I possibly can. In the next video, we are going to talk about circuit protection devices, control devices, where voltage should drop and where it shouldn't, and then we'll get more in depth on the electrical symbols. So I will see you guys in the next video.